Today we're going to look at lesson 7.2, which is about multiplication properties of exponents. So that's our objective. Today we are going to use the multiplication properties of exponents. So if we are wanting to multiply powers with the same base, okay, I want us to think about this. So let's think about x to the fourth power. Okay, hopefully remember if we see something like x to the fourth power, it means that the base is x, the exponent is 4, and so as repeated multiplication, it's x times x times x times x. So there are 4 x's. Now, what if we have x to the fourth power times x to the third power? So if I have x to the fourth power times x to the third power, well, we already know what x to the fourth is. We just talked about it above. I know that as repeated multiplication, it's x 4 times. Now I want to multiply, and now I want to think about x to the third power. Well, the base is x. Its exponent is 3, so that means I want to see x 3 times. Okay, so this represented the x to the fourth. This represented x to the third. And so now think about it. How many x's do we really have? Well, we have 4 of them in the first group. We have 3 of them in the second group. So that tells us that there are 7 x's. And so that means that we have x to the 7th power. So the question is, what did we do with our exponents? Hopefully you're all screaming at the screen right now and you are saying the answer. We added. Notice that 4 was the amount of x's in the first one, 3 was in the second, and so notice that that became 7 as a total. So the fact that they have the same base being multiplied together meant that we added our exponents. That's the definition that I'm about to write. So it says to multiply powers that have the same base we are going to keep the base and we are going to add the exponents. Okay, so we keep the base and we add the exponents, but that's because we are multiplying bases that are the same. And so to kind of demonstrate that with variables, say I have x to the power of m being multiplied by x to the power of n. Both of those are bases of x. With those exponents, then I keep the base and I'm adding the exponents of m and n together. Okay, so let's use this definition to look at some examples. So in the first example, we've got 4 to the third power times 4 to the fifth power. Notice that they both have the same base. They both have a base of 4. So because those bases are being multiplied, we get to keep the base and I get to add the 2 exponents. So we get to add the 3 and the 5 together. Well, 3 plus 5 is going to turn it into an exponent of 8. So 4 to the power of 8 would be my answer. And I don't need you to multiply all that out because that's a pretty big exponent. So we would just leave our answer as 4 to the power of 8. In the next one, we've got negative 3 times negative 3 to the 6th power. Notice that the base is in parentheses negative 3. So remember, that means that if I have the same base being multiplied, I get to keep that base exactly how it is, and I want to add the exponents. Remember, there is an exponent with that first base. If you don't see an exponent, think about how many of those bases you have. You have one of them. So think of it as an exponent of 1. So that means I get to add the exponents of 1 and 6 together. Well, hopefully we're okay. That 1 plus 6 gives us 7. So we have to keep the negative 3 in parentheses. It's raised to the 7th power. That is our answer. In the next one, we've got y to the 3rd times y to the negative 4th times y to the negative 5th. They all share the same base. Even though there are 3 of them, they all have a base of y. And so because all of these are being multiplied, we keep the base, and now I'm going to add 3 plus negative 4 plus negative 5. So we get to add 3 exponents. Well, if you use your calculator to add those exponents, we end up with y still the base, but we get negative 6 for our exponent. And now this is where you have to be careful. I am not going to circle that and say that it's my final answer, because if you notice, there's a negative exponent. And remember, we never want negative exponents. So if you think back to our last lesson, I'm going to make this a fraction since I don't see one. The negative exponent is in the numerator. So that means this entire term that has that negative exponent is going to move down to the denominator. So in the denominator, now we'll have that base of y because that doesn't change. The exponent becomes positive. Since there's nothing else in the numerator, we get to put a 1. And so 1 over y to the 6th power would be my answer. In this next example, we have negative 3x to the 7th power times 5x to the negative 2nd power. Notice that this is all multiplication. But in this problem, there are a few just numbers. They don't have exponents with those numbers. The whole point, though, is that this is a multiplication problem. We are multiplying here. So if I have two numbers like that, we actually get to multiply those numbers. So negative 3 times 5 is going to give me negative 15. Now notice that we've got several x's. That means they have the same base. So remember, I keep the base, and now I get to add those exponents. So I get to add the 7 and the negative 2. So I get to keep the negative 15. I keep the base of x. 7 plus negative 2 will give me positive 5. Even though that 15 is negative, it is not an exponent. So we don't have to worry about moving that. Every exponent, which in this case is just the 5, is positive, so we're good to go. This is our answer. Okay, there are a couple problems here where sometimes I am going to ask you to fill in the blank. So basically what we're trying to do is we're trying to find the number that goes in the box. So we're trying to find an exponent. So to do this, we really just want to think of this as an equation. What I don't know, I'm going to call x. Notice how I have the bases are all the same. And so because every single base is the same, what I'm going to do is I'm going to ignore those bases. Now, if the bases were different, we couldn't do that. But since they were all 7, I'm going to ignore them. Notice that because this was a multiplication problem, we are now looking at the exponents. So just like our definition, exponents we add. So I'm going to have negative 2 plus x, and that's going to equal 23. So I'm just focusing on the exponents. But because it was a multiplication problem, we add exponents because the bases were the same. So now we just have a one-step equation. I got to get the x by itself. So I'm going to add the 2 over to the other side. That'll get me x by itself. Well, 23 plus 2 is going to give us 25. So I'm just going to circle that number because actually that's the number that should go into the box. That is my answer. Notice that in the next one, I once again see an R for a base, an R for a base, another R for a base. So because all the bases are the same, we just have to focus on the exponents. So once again, I'm trying to figure out what that box is. I'm going to put an X. Because the bases on the left are being multiplied, when I start ignoring the bases, I have to add the exponents. Oops, that's a 17, not a 14. So we have X plus 17 equals 1. And so now my goal to solve for X is move the 17. So the opposite of a positive is a negative. So I'm going to subtract 17, and that is going to then give us X by itself. 1 minus 17 is negative 16. That is the number that goes in the box. That is my answer. I'm going to ask that you pause the video and see if you can come up with these two checkpoint problems and then unpause it to see my answers. Okay, so hopefully you paused it. I'm going to run through it really quick. Notice that my base in this first one is -4 in parentheses. Because it's the same base, I get to keep that base and I get to add the exponents. Notice that 3 plus 6 gives us 9. Because my exponent is positive, I am done. I don't care that my base is negative. Exponent's positive, I'm finished. In the next one, notice that all of the bases are the same. My goal is to figure out what this exponent is. I'm going to call that X. So in order to ignore the bases, I have to add the exponents and set it equal to this other one. So notice that I need to subtract the 8 to get it to the other side. So that gives me an exponent of 11 minus 8, which is 3. So 3 is my answer.